So the packet rerouting is important. The fixed channel assignment also limits flexibility. So these are some of the inefficiencies. So what are some of the open research issues? These are a list of all the open research. Scalability is an issue. The MAC is still not fully solved because it's still, some of them still are not able to deal with the hidden node and exposed node problems efficiently, right? And whether the MAC protocol can deal with all this will depend on new ideas, I guess, right? Many of the ideas still leverage on ad hoc network approaches and trying to extend ad hoc network approaches. The last point is about heterogeneity here, because you're usually in mesh networks, you're not dealing with just one wireless technology, you're dealing with multiple wireless technologies. And here are others. Right, so I already mentioned this one. Multi-channel protocols with multiple transceivers are still in development, but as long as you have multiple transceivers, costs will go up. So although you may have multi-channel protocols for interoperability reasons or for flexibility, if you want a simpler solution, you still have to provide a backup single channel solution. Not in all implementations will have the full flavor of the type of capability of the whole system. So some systems will be more restricted, so you have to deal to cope with that, and so you still have to have the single channel solution. All right, and so there's still much research going on. Another point here is to use software rather than firmware. Firmware, you burn it into the chip, cannot change anymore. Okay, so software-defined radios and all that will start to come in, and they're beginning to come in. So there are already people manufacturing, especially for 802.11 chipset. Right, so the future is for software radios, so that you can change the protocol easily. So that's the MAC. Any questions? Okay. Routing, I won't say too much because a lot of it is still, to some extent, are variants of the routing that is used in network. Okay. So these are all the desired requirements in terms of good routing protocols: scalability, fast discovery, able to deal with mobile nodes, flexibility, quality of service support, and being able to do multicast. Multicast means that you can send the information to a smaller group, not full broadcast, smaller group of neighbors. Okay. And what are the criteria? Minimum hop is usually one of the criteria. All right, and minimum hop will depend on some of those issues like interference, delays, error rates, and power consumption. You want maximum data rates, you want maximum route stability. You might want to use multiple routes for resilience, for example, or use multiple gateways to get to the backbone in a more efficient way. You know, if you have to make many hops to a particular gateway, and you have a choice of several gateways to choose from, common sense will tell you, I pick the one which is nearest to me. Okay. So multiple gateways are useful in that sense. And then you can have a combination of the above. Okay? So we talk about proactive, we talk about reactive, so I'm not going to say more about this. All right, and those protocols can also be applied to mesh networks. Okay, provided you take into consideration that mesh networks usually want to get to the backbone at some time. Okay, so one of the research work that we did must be quite a few years ago, at least 5 years ago. All right, so when I had a student, PhD student, his work was: you have a mesh network, you have all these gateways. you're a new node coming in. Who should I belong to? Which gateway should I belong to? In terms of having the best trade-off of getting the gateway as soon as possible, as well as this gateway doesn't get too overloaded with too many clients. If everybody say, this is a good one, everybody go there, this guy will die, right? Because it's overloaded. So you need to distribute. You need to distribute out the nodes so that the nodes will each have a fair share of number of clients. All right? And then you take into consideration the multi-hops as well. How many hops are you prepared to tolerate to get to the backbone? So all this optimization comes in, and that was his PhD work. Okay. So anyway, we talked about a proactive and reactive already. So these are variations from what we saw in ad hoc networks. And of course, we have hybrid networks, hybrid routing protocols, all right? Which is a combination of proactive and reactive protocols. Hybrid protocols may be actually better for mesh networks because of the nature of mesh networks. Since you want it to be scalable, and you want to deal with mobility, and you want to deal with gateways and routers. Okay. The other approach would be to have some kind of adaptive routing protocol where the behavior will be modified dynamically by monitoring change in the network conditions. Okay. So, as I said, a lot of the protocols are variants of ad hoc networks, so we won't go into that. Now, what has also transpired regarding the design of all these protocols is what performance metrics do we use in this design? Okay. Now, the obvious ones are like latency, number of hops and all that. Those are the obvious ones. But there were quite a number of other different types of metrics that have been proposed. Okay. So the preference is to use a combination of metrics. So what we call multi-dimensional metrics, combination of metrics. Okay, that should include one or more, preferably more, of the following, such as the quality of service, power efficiency, latency, security, reliability, etc. Okay, so ideally, you have a joint performance metric that gives you the best trade-off. Because some of these they are competing against each other. You do well here, you do bad here. All right? Okay? So they are trade-offs. They are not all moving in the same direction. So these are the desirable characteristics. Okay, the first one is isotonicity. Now, what is isotonicity? What that means is this. If you have weights for paths, okay, you have a certain weight for this path, a certain weight for that path, okay. The higher weight, the more probable you take that path. Okay. The order of these weights should be preserved, even if there is a third party consideration of a new node coming in. It doesn't change that order. All right, that's what it means. Order of weights of two paths is preserved if they are appended or prefixed by a common third path. All right. So, example. I have two paths here, and one A, B, and C. A to B. All right. A to C. Each of it is the weight. Now, if I have another path possible, A, D, B, A, D, C, the weightage of this should be preserved. That's what it's saying. It shouldn't change the order then. It shouldn't change the order that this is now higher. Just now this was higher, now this is higher. No, it shouldn't be that. All right, that's what isotonicity means. Okay. Second one is, if you are aware of the degree of interference around you, can I make use of this information to improve my routing? So obviously, yes. right? If you have some knowledge about the extent of interference, okay? If you have some information of the local locality around you, okay? Awareness of the neighborhood, will it help you? Of course, yes, and that's where hello packets come in. You are sharing information with your neighbors, so that information is always helpful. You like to have a system that practices load balancing, so that you don't congest a certain part of the network and that one cannot move anymore. Do load balancing, okay? Of course, you like agility, because if network conditions change, then you know how to reroute things such that you avoid further making that situation worse, okay? So you want that to be done very quickly, obviously. And finally, as far as the end nodes are concerned, you want good throughput, effective throughput. If you send something, it gets through, not having to try over and over again. So these are the desirable characteristics. And these are some of the common metrics which different researchers have used. So the top will be hop count. Okay, the less hop count, the better. The second is round trip time, how long it takes to send something, a ping you like, no? Round trip time. Time to send probe and receive probe acknowledgement. The next one is expected transmission count. That means how many times on the average do you need to try again? Expected number of transmission for successful packet delivery. ETX. The fourth is expected transmission time. On the average, how long it takes before you are successful. Then you have the weighted cumulative ETT, which is the weighted sum of all the ETTs along that path. ETT is the expected transmission time. Then you can have metrics for the interference and channel switching. So this accounts for the interference in your neighborhood. The next one is interference load aware. So it combines interference and loading statuses. Right? Loading will be, for example, how much traffic is there. Sometimes it's very hard to measure how much traffic, so you use proxies. Example of a proxy is your queue length. How long you have to queue before you can get out of your output port. Okay, queue length. Then the next one is load aware ETT. Combines ETT with load awareness. Another one called effective ETT. Combines ETT with interference awareness. And finally, interference aware metric. So you can have all these combinations to do it. So I don't know if it will help, but there are a couple of examples here that we can mention. I had another project student who was working on wireless mesh networks, and he was designing optimal routing protocols using a method called reinforcement learning. Have you heard of reinforcement learning? Okay, so reinforcement learning requires you to discover the state of the network, and based on the state of the network, you take certain actions. Okay, so you need to learn about the state of the network and how do you provide this information end to end so that you carry out the right actions or decisions. Okay, so it's called a method called Q learning. All right, it's pretty powerful. It's complicated. All right, but the biggest problem with these methods is the overheads, because there's a lot of information that needs to be shared across the network, and if the network is very dynamic, it's very hard to stabilize. because things are changing too fast and your overhead cannot catch up. Okay? So, here's one example. This is the paper is down here. 802.11s, okay? It's the wireless LAN mesh standard. So this is what you have in the new boxes. Remember the one that you buy in pairs? Okay. So it combines on-demand route discovery with proactive routing to a mesh portal. On-demand routing offers flexibility in changing environments. The proactive tree-based routing is very efficient in fixed mesh networks and suitable for relatively fixed topologies, which is what you have for Wi-Fi. Okay, relatively fixed. It includes multi-hop capability. Okay. It uses a simple metric called the airtime. It does provide support for other metrics. So it's a modified form of AODV called the radiometric AODV, which we already know as AODV, right? All of you know that, no? Okay. And extensions to identify the best metric path with arbitrary path metrics. So this is the extensible part of the protocol. So destinations may be discovered on demand. So let's look at an example. So you have four device classes, as you can see here. You have the mesh point, all right, mesh point. Two types of mesh point though. You have the AP mesh point, mesh AP. So the functionality of the mesh point is co-located with AP function. That means it's like a the wireless router, which provides basic service set, DSS basic service set to support communication with the stations. Stations are disguised. That means like your devices, your mobile phones, your laptop, etc. Then you have the mesh portal, which is this guy, which connects to the external network. All right. So you can think of it this way, in a typical home environment, this guy here is your set-top box. Okay, it's a set-top box. This is the one that most of you are now eventually converting to from Singtel or StarHub, which has the optical fiber. Right? StarHub says they want to move everybody. Well, Singtel has already moved because Singtel has already discontinued their ADSL service. Those of you from overseas, you may not be aware of this. All right. Background is that basically for broadband services, there were two primary providers in Singapore: Singtel and StarHub. Singtel uses a twisted copper until last year, I think, where they discontinued that. So anybody who used this twisted copper, which is the ADSL service, they had to move over to optical because they were discontinuing it. Okay? StarHub was using cable TV, cable modems. Okay? StarHub will be discontinuing their service in the middle of this year. So if you're on StarHub, you have to move over to optical by the middle of this year. But I don't think it will happen by the middle of this year because they have a huge backlog. Okay? I have both. I converted my Singtel, I think sometime last year, early last year. Okay? But my StarHub, I can't even get an appointment. They say they want to finish a promotion in middle of December. They have to push the date until March because there's a huge backlog. You can't even get an appointment. Alright, so they're moving to optical. So that's where this guy is, the set-top box here. Alright, then you have the wireless router. Typically, you have your wireless router here. Alright, and then these are mesh points. So they do the multi-hop. Alright, do the multi-hop. So my house has 4 levels. So one wireless router will not cover the whole house. Even in an apartment, it cannot. Especially if you have a maisonette, it is 2 levels. If you want to put in 1 level, you cannot reach the other level. Right? Yeah. So this is where the MP is the mesh point, will give you the multi-hop. And then you have your own devices. Okay? Your mobile phones, your laptops, etc. Okay? Yeah. So that is the 802.11s. Right? So for the root part, the root discovery part, okay, you have the proactive routing. So it uses a tree-based routing, and this is a root, and then you have the child, okay? It's tree-based routing. It's very efficient for hierarchical networks. Also avoids unnecessary discovery, flooding during the discovery stage. Okay, these are some of the messages that goes through. All right, so you have the root announcement. This is the root will announce its presence. You have the root request. It asks the destination mesh point to form a reverse route to the originator. You have a root reply. It forms a forward route to the originator and confirms a reverse route. And of course, if anything goes wrong, you have also the root error message. Okay, the on-demand routing, the key features will be to allow the nodes to quickly obtain routes for new destinations because it is already able to do that on demand. The route discovery uses an expanding ring search to limit the flooding. Now, if you think about it, the extending ring is a variation of Bellman fault. Bellman fault is by hops, right? 1 hop away, 2 hop away, 3 hop away. So it's kind of like an expanding ring, but this is a variation of that. So the reverse path is set up by the root request, packet broadcast, and the forward path is root reply. Okay, so it's similar to RREP and RREQ. Okay, root maintenance is the nodes monitor the link status, and if a problem occurs, they will send off a root error message, and this will trigger a root maintenance as a result of that. The network is free from loops, so that's good. Okay, this is based on the BSDV and AODV principle. So it's actually variation, as you saw, a variation of the AODV protocol. And all nodes own and maintain a destination sequence number, which guarantees loop freedom of all routes towards that node. Okay. Then the tree-based routing, these are the key features. It has a root mesh point. It issues the broadcast root request, and then the mesh points will respond with a root reply, and the root MP may issue root announcements, and then the mesh points may respond by a unique root request to the root, which is answered by a root reply. MP select next hop to route based on the best path metric, so there will be certain path metrics. And the best path propagates down from the root. Registration of subtrees by MPs facilitates outward messaging routing, message routing. There is group topology maintenance when things go wrong. So MPs do the mesh points, monitor the upstream links, and make sure that everything is fine, and this allows the nodes to decide or select own backup paths in case anything goes wrong. Okay. So there are other additional options, all right, that uses link state information. This is a variation of a protocol called optimized link state routing. Okay. RAOLSR. So this is used to proactively maintain the link states. Link states is the quality of the link. And changes in link state are communicated to the neighborhood nodes. So extendable extensible routing schemes based on two link state protocols. These are protocols that have been around for quite some time actually, OLSR. And the extension is to be aware of the radio quality. That's why we call it radio aware. Okay. So there's another one called Hyacinth. I don't think I want to go into detail. The details are here. So again, part of this this module is not really to go into the exact details, because as I say, you go to exact details, we have to go through all the maths of how this performs. But it's to give you a broad overview. Okay. So this is using multiple radios. This is Hyacinth. Okay. Multi-channel, multiple radios. Okay. And so on. The details are there. Then this is another one called MCR, multi-channel routing protocol, for dynamic wireless mesh networks. Okay. So what you find is that actually a lot of these are variations of each other, you know. All right, variations of each other. They may vary because they're using different metrics in the design of the algorithms, for example. Okay, as you saw, there's a whole list of metrics just now. Okay. Or they may have certain assignment algorithms for channels, certain assignment algorithms for radio. Yeah. This is MCR again. So again, this is a summary of some of this. Okay. Now, if you really want to go into details of this, by the way, a lot of this content came from one textbook, wireless. I forgot the name already. I'll send it in an email to you guys. Okay. So you see, if you want to read up the details, so a lot of it came from that particular textbook. Let me get it and see what it is now. All right. But before that, I got a couple of slides before. So these are some of the research issues that still people are looking at. Scalability is important. What set of metrics to use? All right. Capability for multicast, cross-layer design. Okay. And combinations of this, if you like, combinations of this. Whether you use multiple radio, multiple channels, or a combination of the two. Already mentioned cross-layer. And then most existing routing protocols treat all network nodes the same way, but now you see more variations in the types of devices, etc. So these are some of the references. Okay. So let me just pull up and see what is the name of that text. Just give me a name. So the name of the textbook is Introduction to Wireless and Mobile Systems. Actually, I took a lot from a couple of books. Intro to wireless and mobile systems. So this is by Agrawal and Singh. DP Agrawal. some content is this one. The one is this one. Wireless communications. And this is by V guide. Okay, those two books. So you want to read more? Huh? Okay, so any questions? Okay, if there are no questions, so next week we will cover the last topic, which is on TCP/IP. Okay, TCP/IP as a background, TCP/IP was originally TCP/IP stands for Transmission Control Protocol / Internet Protocol, right? Originally designed 40-50 years ago for wired networks. Okay, so I will give a brief introduction about how TCP/IP works to ensure reliable transmission. But because it was designed for wired networks, it will not work well for wireless networks, because the quality of the channel is so bad in a wireless environment. So other things have to be done to help improve that situation. Okay, so we will complete that, and then we will also complete our last tutorial. Because the week after that, there's no class because I'm traveling. Okay? Alright, so I will put some of the past quizzes up so that you will have some practice. Okay? Alright, but I am available anytime you have questions. Feel free to email me, feel free to WhatsApp me. Alright, anytime. Okay? I will also send a video link from Kind Phuket, who's doing all the video capture for us. Alright? And when we come back, for those who came in a little late, I don't know whether you saw this. Okay. Okay. So on week 8, it's not week 7. Week 8. So week 7 you will have class. Prof Tam will start after the recess. But week 8 we'll come here and we have our midterm quiz, which will start at 7 p.m. So hopefully all of you can make it in time. So we'll be late. Okay. So if you look at the past quiz question, you will have some idea what the format is. Okay. 20% count. Yeah.
Will there be class before 7 p.m.?
No, only the quiz. Yeah.
How about the makeup lecture during the...
No need makeup. Next week is my last lesson. Finish. Yeah, next week is my last lesson. Okay? No need to makeup. Alright? You might have questions for me when you try the past quiz question. Alright? Because I'm going to put it up on the Luminous. Okay? onto the folder. Alright? So if you want to ask me question, after you've done your answer, send it to me. Okay? Take a picture. I don't know, I can come if you want to. I have left it open right now. Okay? If you want the makeup, I already covered the content by next week. So if you want makeup, it's either to answer questions, because we already have finished our tutorials. So maybe you have tried some of the quiz thing and you're not sure of answer. Sure, we can have a makeup and have a Q&A. I'm okay. Do you want that? Because you can also send me the answers. As I said, take a picture, send it to me, whether it's WhatsApp or email, and then I'll tell you whether you're right or wrong. Very easy. Huh? So do you want a makeup, or you want a clinic or a Q&A? I heard an answer no yet. I'm okay, I'm not going anywhere. I'm only going on the week 6 or so. So I take it no, answer is no. Okay, but as I said, I am available. If you try any of the past quiz and so on, take a picture and send it to me. Alright, and then I'll guide you along the way. Okay? You have my number, you have my email. Okay, it's, I believe, on the first slide of the first set of notes. Right? Okay? Okay. So please put it into your calendar. Alright? Try to come at least 15 minutes earlier, because I need to seat you all guys so that you are one hop away. Okay. And finally, again, I will ask again, is Yo Hui Su here?